In this video, I'm going to go through some of the typical questions you might be asked about Surds, which is to simplify Surds. Simplifying Surds implies that you'll have to use all of the properties that we've discussed in the previous two videos. So collecting like terms, making sure that if you square a square root, you're back to the integer value at the bottom of the surd, and multiplying surds and dividing surds. So you'll have to use a combination of all those properties. Make sure you've practiced enough questions on those, you've understood them before attempting these questions. So when you simplify surds, you are expected to make sure that the number under the radical or the surd is the smallest possible. So in this case, let's say if I have, for example, square root of 28. Well, I can use the third property about multiplication. This is where it becomes useful. Again, it might not seem very intuitive to use the multiplication property, but as soon as you see a surd with the number, with a non-prime number underneath, so 28, it's not a prime number, so I can't split it into two numbers, two of its factors, and it's also not a square number. We'll try to split it into two numbers such that one of them is actually a square number. Immediately think of using the third property for multiplication. So try to get that in your head. That's the trick part of dealing with surds. It's when to know when to use these properties. For now, when you just have a surd and there's a number underneath, you have no idea what to do with the number, split it into two different surds. So a square root of 28 can be split. You can look at all the different properties, all the different factors, so you can split it into 4 times 7. And then again, we're going to use the third property, and this can be split into square root of 4 times square root of 7. Well, we know what the square root of 4 is, and that is actually 2. So it's just 2 times square root of 7, which is just 2 square root of 7. So this is you simplifying the surd, writing it in the simplest form. Now we've actually satisfied the condition that the number under the radical or the surd is the smallest possible. So 7 is the smallest number possible. Let's try another one. Let's say you can try another set of numbers. You can try with any number possible. Come up with your own numbers. Sometimes calculators write the surds for you as well, as in simplify the surd for you. So you can try any number, do the calculation, and check it with your calculator. Or you can attempt the questions in the book. I'm going to advance it slightly further and say, let's say you have 2 square root of 2 times 5. Sorry, square root of 5. Well, in this case, again, we're dealing with them like algebraic terms, so you're just going to multiply the coefficients. In this case, it's 2 times an invisible 1 here. So that's 2. And then you want to use the third property with these two surds. So you're going to say, well, that's actually 2 times 5. You are allowed to do this because you have a multiplication. Remember, if you have an addition, you can't simplify this because they're not like terms. In this case, we can use the third property because it's a multiplication, so the 2 goes to the front, and then it's a 2 times 5 underneath the surd. So this is 2 square root of 10, and then I can't simplify it any further. So this is as simplified as possible. I'm going to give you this one. Do pause the video and attempt it, and then resume to see the answer. So for this case, it's just 3 times 2, so I'm multiplying the coefficients, that's 6, and then the 3 and 2, which are underneath the surd, can be put underneath a 1 surd, and this will be 6 square root of 6. Now you don't need to write this exact step, you can immediately go to this step, but it's always good to write that just in case you're still not confident with dealing with surds. At least you have a track of where you are so far. So a last one will be this. This time we have 3 terms. So in this case, we can still complete the same thing. We have 2 times no coefficient, so we have the 2. And then now you could immediately spot that 2 square root of 2 times square root of 2 will actually just give you a 2, but using the first property, but I'm just going to put all the surds under a 1 surd. If you spotted what I just mentioned, then well done. Otherwise, I'm just going to continue. So in this case, I have this will give me a 4 times a 3. Well, I don't really need to go through this because I know I can split it again to square root of 4 times square root of 3, which is 2 times, this will give me so this precise root will give me a 2 times square root of 3, and so this is 4 square root of 3. So I didn't really have to go through this long step. I could have easily spotted that the square root of 2 and the square root of 2 would have given me 2. So that's 2 times 2, and that's a 4 in the front, and then I'm left with the square root of 3. So I'm at the end. But again, if you're still unsure about these properties, it might be a bit confusing to do these quick steps. Do go through from the beginning. So it's 2 times 2 times 2. If you actually left it as 2 to the 2 and square root of 12, this would not have been the simplest surd. The number underneath the surd cannot be simplified further if it's actually a prime number, because it can't be simplified any further. Otherwise, if it's not a prime number, then you can actually simplify it further down. I'm gonna go through a slightly different type of question. Some questions will ask you to write numbers in the form, so they wanted more specifically, it's still using the simplifying method, but they wanted it in the form of a number and then square root of 2. So that's literally what they mean. K doesn't matter, it could be any number, it just means any number, and then square root of 2. So I'm going to put up a couple examples. Do follow the same steps as we've done before. Pause the video, attempt these questions, and then I'm going to go through the solutions. So for the first one, it's going to be, well, square root of 8 can be reduced to 4 times 2. And we know that square root of, I can split it again to square root of 4 and square root of 2, and the square root of 4 will just be 2 square root of 2. So I do have this form. The k in this case is 2, and then I have a square root of 2. Well, in this case, I have a square root of, the easiest thing to spot is square root of 100 times 2. Now you can try different numbers, and you might end up with the same answer, or you might be stuck and then you have to try another factor. So this time I have square root of 100 times square root of 2. See how useful this property is. And then square root of 100 splits is actually just 10. And then you have the square root of 2. So quite a useful property to have. Another type of question you'll be asked for simplifying is when you are faced with addition. So again, in this case, remember I told you you're faced with a square root, you have no idea what to do, it's a bit of a weird one. Well, square root of, you can evaluate the square root immediately. In this case, it's quite easy to spot. It's 4 plus, and then this is 3. And then you'll have to simplify it further, obviously, so that's just a 7. In some cases, it won't really simplify. So let's say you had the square root of 18 plus the square root of 10. Well, in this case, I can simplify it by splitting this 18 into, say, a 9 times 2, and then square root of 10 could be 5 times 2. 9 times 2 can be square root of 3, sorry, not square root of 3, it's square root of 9 times square root of 2 plus the square root of 5, square root of 2. The square root of 9 is just 3 square root of 2, and then you're left with, well, this actually doesn't simplify, so I can change it back to the square root of 10. I know I said a good indicator to whether you've simplified it further is if you have a prime number underneath. It's a good indicator, but not necessarily always true. That's why I've split this 10 down, just to prove that actually you can't even, you can't simplify it any further. So you're left with this case. So this is as simple as it goes. I can't collect like terms, and I can't simplify it any further. And I can't use any of property 3 or 4 because it's a plus between them. So that's as simple as it goes. Then you might be asked another type of question, which is the last one. If you're asked to write, for example, write 6 square root of 2 as square root of n, where n is an integer. Okay, remember this is how we write integers. So you need to write this as an integer. Just pause the video, have a think about it. So if I want to write this as an integer, it means I need to get the 6 back inside. To get the 6 back inside, I need to undo the square root, which is to actually square the number. So this is the same as saying, well, 6 squared times square root of 2. And I can put them under the same surd times 2, and this is 36 times 2, which is square root of 72. This is one of those interesting type of questions. They don't pop up as often, but it's quite nice to see how you can undo a simplification. So these are the questions on simplifying surds. A couple of last videos will be on expanding and rationalizing surds.